Alright, now how will we find these dependencies? How are we going to shrink our problem and decompose this matrix into two smaller matrices? Yeah? The first thing we need to do, we need to choose features. How many features? Well, this is a hyperparameter of this problem. We don't know. The best would be to do cross-validation. Keep a cross-validation set in order to find the optimum number of features. In this example, we will select two features. One is romance and one is thriller. Yeah? So what have we actually done? Yeah? We have 5 movies, 3, 4, 5, yeah? And we give them a score with respect to these two features. Yeah? Okay, so here you have 5 times 2, you have 10 elements. And then we do the same with the users. So we have 4 users. Yeah, and here we do again the same thing. And here we have 2 times 4 is 8 elements. So if we add them all up, it's 18. So by choosing 2 features, I reduced the size of my matrix. And remember, this matrix is a 4 by 5, is 20 elements. And the benefit doesn't seem to be big, but what if we have I would say 2,000 movies and 1,000 users. So here your rating matrix will be, the number of elements will be 2 million. 2 times 10 to the power of 6, 2 million. Yeah, is this multiplied by this one? Yeah, the same as we have here. But assume that you set 100 features. Yeah, then this one will become 2,000 times 100 is 200,000. 10 to the power of 5, and here 1,000 times 100 is 100,000. That is 10 to the power of 5. We add them all up, it's 300,000. 300,000 element versus 2 million. So you save a lot of space by doing that. And the fact that there are many dependencies, it's actually quite easy to decompose and to find the features. Okay, before we move on, I put things a little bit different here. Yeah. So this is still our rating matrix R. This we will call our user matrix, U transpose. And this is our item matrix, I. And what does the process should be that we decompose R as a product of U transpose I. Yeah? So we take a complex matrix, a larger matrix, because this is here a 4 by 5. Yeah? And we make 2 smaller matrices. This is 4 by 2, and this is 2 by 5. Yeah? So this all fits. Now decomposition of a complex matrix into 2 more simpler matrices is called matrix factorization. Yeah, it's matrix factorization. Okay, some of you may remember we came across matrix factorization when we discussed dimensionality reduction. It's not a coincidence, because basically what we do here is we also reduce the dimensions. Yeah? And we've seen 2 techniques to reduce dimensions. One was PCA, principal component analysis, and the other one was SVD, singular value decomposition. So it's similar to singular value decomposition. Decomposition. Okay? Singular value decomposition, also called SVD. What was singular value composition? Well, it allowed us to decompose a complex matrix A into three matrices. Yeah, U, sigma, and V transpose. Yeah. What did it mean? For example, U is a rotation, sigma is a stretch, and V is another rotation. Basically what it says is an A is a matrix, yeah? And a matrix is nothing more than a linear transformation in space. Yeah? What does a matrix do? Well, let's look at these simple matrices here. You could have a triangle like this. This is your initial state. Then you're going to apply U on that triangle. That triangle will rotate. Yeah, you will have maybe something like this. Yeah, so that's a rotation. Then you apply sigma to it, and when you apply sigma, this thing will stretch or shrink. Yeah, suppose it will shrink. Yeah. And then you apply the other transformation, V transpose, and then basically what you do is you rotate once again. Let's make it like this, yeah, where here you have the angle. So these are three transformations you do, yeah, and these combined give you one transformation A. So this would be U sigma V transpose. If you would look at A, you would go from this immediately to that. Yeah? This is also matrix factorization. By the way, singular value decomposition has been tried out for this collaborative filtering. The problem, however, is that you cannot apply singular value decomposition on a matrix with blanks. Yeah, that's why it is not an ideal situation. Yeah, but the intuition and the concept is the same. You have something complex and you decompose in simple things. Here is exactly the same. Complex rating matrix, and you try to decompose it in an I, N, and U transpose matrix.